All right, and we're back at it. Another day, another great day for algebra, learning math. I know you're super excited about that. So today we're moving on to lesson 5 in unit 1, which is quadratic functions and table of values. So this should be the note sheet that you have out in front of you. So make sure you open that and have that out in front of you. I want you to take some great notes, all right, and have that. All right, so once again, we're just kind of keep asking the same questions. We're going to keep coming back to the same concepts, but looking at it, all right, through a different function. So today's emphasis is going to be on a quadratic function. So we've had linear, we've had absolute value, and now we're getting to our quadratic functions. All right, so once again, the standards look very similar, right? Really the three same questions. I can identify a quadratic function from a table of values. I can identify the rate of change for a quadratic function from a table of values. And I can find those missing values or extend a table in either direction using my knowledge of rates of change for quadratic relationships. So, all right, so really it's the same ideas, right? But now what do I need to see in order to know it's quadratic versus linear and absolute value, which we have discussed previously? All right, so to get you thinking about this, all right, okay, we have this situation here, right? So I'm going to read the opener here to you, and then I'm going to give you some time to fill out the table of values, all right, and answer the three questions. So this table of value represents a penny being dropped from the top of a building that is 1,000 feet high. Determine when the penny will hit the ground. Now, here's what I'm going to tell you. Look at those rates of change for x, which is time in this case. Look at the rates of change, or see how the change in y is changing, all right, for our height in feet. Now, this is a little bit harder, so the pattern isn't as evident with a quadratic, all right, as some of the other things that we'll talk about. So, but I want you to pause the video. I want you to look at those numbers and see if you can find that pattern, all right, and see if you can figure out when the penny hits the ground. And then, like you said, I've got already given it away, right? It's a quadratic, right? So we should kind of know what this is. So pause the video, give it a shot, and turn it back on, and we'll see how you do. All right, so let's take a look at this table. Now, once again, we can see that the x values, all right, they're all increasing by 1 second, right? So we're going up by 1. Now, here's where the challenge comes in. Now, there are some things that will help us, and I'll talk about that as we go through, because right now we have three functions that we're looking for: linear, absolute value, and quadratic. So look at our first rate of change. We go down by 16. All right, so we have 16 to 1. All right, now if we look at how y changes on the next set of problems, or the next set of data, we go down 48. Now here's what we know right now. We can throw absolute value, we can throw linear out the window. They're done, they're gone. See ya, right? Because they know they have to have a constant rate of change. So negative 16 to 1 and negative 14 to 1, or 48 to 1 are definitely not equal. So as soon as we see these two rates of change, and we know when we reduce them that they do not equal the same value, all right, it automatically throws linear and absolute value out of the window. So right now we're down to quadratic because we haven't talked about exponential yet, but we also know that this is a good way to think about problems to eliminate some things before you move on. So now look at that next change. We go down by 80. All right, next change, we go down by 112. The next change, we go down by 144. So now here's where this gets a little bit complicated the first couple of times you see a quadratic pattern. All right, it's hard maybe for some of you to see the pattern in those numbers, but there is a pattern in those numbers, so let's look at it. All right, so when I go from negative 16, negative 48, negative 80, negative 112, there is a pattern. All right, and so let's look at what's happening between the numbers. So when I go from negative 16 to negative 48, it decreased by 32. Well, what happens when I go from negative 48 to negative 80? I decrease by 32 again. And then when I go from negative 80 to negative 112, I subtract 32 again. So the pattern here is that the way I get the next number is I subtract 32. So to get the next number after negative 112, I need to subtract 32, and I get negative 144. So then I have to subtract 32 again, and I get negative 176. And we could keep this pattern going, right? Just keep subtracting 32 on and on and on for as long as we needed to go. So the pattern for a quadratic is what we call the second difference. It's how those numbers are changing. They're always going to change by the same amount. So they're either going to all go down by 32, or they're going to all go down by 6, or they'll all go up by 4. And you'll see what I mean by that as we look at some more examples as we work through the lesson. But let's go back to that opener now. All right, so here's kind of where we left it, right? And we said that, okay, here's the pattern, right? You can see that, and that's why we call it the second difference. It's that second column out there, right? The first difference is negative 16, negative 48, negative 80, negative 112, negative 144. But the way those numbers are changing is by subtracting 32. So let's continue that pattern. Let's subtract 32 from 144, and we get negative 176. So 600 minus 176 is 424. So that penny at 6 seconds is still 424 feet above the ground. Well, we have to subtract 32 again to figure out, all right, what do I subtract from 424? So 176 minus, or negative 176 minus 32 is negative 208. Subtract that for 424, and we're still 216 feet above the ground at 7 seconds. All right, so go back to that pattern. Subtract 32 from 208, that's negative 240. So now 216 divided, or excuse me, subtracted, let me start this again. 216 minus 240, all right, gives us negative 24. So now that penny, all right, went through the ground. It's 24 feet under the ground. So what that tells us, all right, is that really that penny hits the ground somewhere between 7 and 8 seconds, probably a little closer to 8 seconds versus 7, all right? And so we've talked about this. It is a quadratic, and we're going to talk about the why, all right, as we go through this. Okay, so now, once again, if you need to pause the video, write all this down first before you hear me say it, or you want to hear me say it and then write it down. Either way you go, all right, but make sure you write it down. Now, key characteristics of a quadratic are a turning point. Now, we did not see a turning point in that data, all right, and so that's the harder part with the quadratics, is that sometimes the turning point is in the data and sometimes it's not, all right, which is why we need rates of change to help us, all right? So even if we don't see the turning point in our data, the rate of change will tell us it's a quadratic, and that rate of change is always going to change by a constant value. All right, like an absolute value, all right, because we have a turning point, it's going to increase or decrease and increase, and that once again creates that symmetry, all right, that we're going to see. So we're going to have a U-shaped graph, like an up regular U, or we could have a U that opens down, all right. So you're going to see some commonalities here between an absolute value, all right, and a quadratic, because they both possess a turning point. All right, so let's take a look at our first example here. So if you want to take your note sheet, all right, and just flip on over to the back side there, we're going to work on the first couple of problems there in your whole class practice. All right, so as we look at our table here, I'm going to flip to my example here. All right, so once again, we want to start with scanning our table. So if we can find a turning point, that really helps us, because we know two functions have a turning point, all right? Absolute value graph and a quadratic. So if we can scan our table and see a turning point, now we're down to two choices, all right? And you can see here I circled negative 1, 4, all right, because I can see that symmetry around it. I go 8, 5, 4, and then 5, 8, 13. So I can see that symmetry above and below y equals 4. So what I know now is I'm down to either absolute value or a quadratic. All right, so it's really big to remember that. All right, so we know it's absolute value or a quadratic. So now this is where rates of change are going to separate, right? We know an absolute value has a constant down and a constant up, or a constant up and a constant down. So we need to look at those rates of change. So let's look at all those x's. All right, so the first couple go up by 1, 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 go up by 1. All right, so all of our x's are going up by 1. So now let's look at how our y's are changing. So now our first change of y is negative 3. So we go down 3 from 8 to 5. Okay, now, if this is absolute value, it would have to go down by 3 again. But notice what happens. It only goes down by 1. So negative 3 to 1, negative 1 to 1 are not equal. Okay, so this is not a constant rate of change. So that means, see ya! Wouldn't want to be a Mr. AV. All right, so we're down to one choice now. All right, so by finding the turning point, all right, we went down to two functions, absolute value and quadratic. By looking at the rate of change, now, all right, we know we're down to one function, which is a quadratic. Now, let's look at the pattern here, because we will have to extend our table here to find the values for 3 and 4. So when I go from 4 to 5, I go up by 1. When I go from 5 to 8, I go up by 3. When I go from 8 to 13, I go up by 5. So now we have these 5 numbers in a pattern, and we have to figure out, okay, so what happens When I go from -3 to -1, I added 2. What happens when I go from -1 to +1? I had to add 2. What happens when I go from 1 to 3? I had to add 2. What happens when I go from 3 to 5? I have to add 2. So we can see that our rate of change is increasing by 2. So to get my next number, I have to add 2 to 5. So my next number is 7, and then 13 plus 7 is 20. To get my next number, I have to add 2. Well, 7 plus 2 is 9, and then 20 plus 9 is 29. So once again, if you're looking at that right-hand side, you see all those plus 2s. That's the second difference. And that's what we mean by it's always going to change by a constant value. And that's exactly how we're going to describe our rate of change. So if I look at that second difference, right, everything is increasing by 2, right? -3, -1, 1, 3, 5, 7, 9. So we just want to describe that pattern, right? The rates of change are increasing by 2, and because it's increasing by 2, that is what makes it a quadratic. So there's the y. I kind of skipped the y earlier because I think it was easier to see it, all right, in our example problems here. All right, so let's move on, all right, to problem 2 here. All right, so once again, very similar situation, right? I'm going to go ahead and click to my example here that has some of the motion stuff, all right? And so once again, we're going to start with scanning, all right? Can you see that turning point? And once again, I'm looking, the symmetry will help me. I see -2, 4, 6, 4, -2. That tells me that there's my turning point, 2, 6, all right? So once again, now that it's 2, 6, there's my turning point, right? I know I'm down to 2 choices. It could be an absolute value. It could be a quadratic, right? Those are the only 2 things that we're going to deal with in Algebra 1 that have a turning point. So now what we have to get to determine if it's absolute value quadratic are those rates of change. So, +1 for our first change of x. +1 for our first change of x. +1 again. +1 again. +1 again. +1 again. +1 again. All right, so all of our x's are going up by 1. So now let's look at our changes in y and see if we get a constant rate of change or not. So when I go from -2 to 4, I had to go up 6. All right. When I go from 4 to 6, I went up 2. So right now, 6 to 1 does not equal 2 to 1. Those ratios are not equal. It is not a constant rate of change. So see ya. All right, you're out of here. So we know we're down to quadratic. So let's continue our pattern here and see what we get. So when I go from 6 to 4, I subtract 2. When I go from 4 to -2, I go down 6. So when we look at these 4 numbers, right, 6, 2, -2, -6, the first thing is they're all decreasing, right? We're going down, right? They're not getting bigger. Now the question is, how are they going down? So when I go from 6 to 2, I subtracted 4. When I go from 2 to -2, I subtract 4. When I go from -2 to -6, I subtract 4. All right, so now we have to work this guy backwards, right? So now we have to go up the ladder. So when I look at my pattern, right, so what number minus 4 is 6? 10. And then what number plus 10 is -2? -12. All right, and I have to keep that pattern going. So what number minus 4 is 10? 14. All right, and then what number plus 14 is -12? -26. And then I work it backwards again. All right, and I can see 18 minus 4 is 14. And then what plus 18 is -26? -44. So once again, if we look at those rates of change, right, we can see that if I work up -6, -2, 2, 6, 10, 14, 18, I can see that pattern going up. All right, if I look at my table of values, I have 4, -2, -12, -26, -44. I can see that those numbers are decreasing as I work up for my values of y. So let that help you. All right, see the patterns of the numbers to know whether those numbers should be getting bigger, they should be getting smaller. That will make things much, much easier for you. All right, so how do we just describe that rate of change? It is decreasing by 4. All right, and then because of that, it is a quadratic function. All right, so now when we think about our work here, all right, I'm going to look at one more problem with you. All right, and so this is one of the ones where I was talking about earlier where we don't see the turning point. So if I scan up and down my table here, I don't see a turning point. All right, so I don't have anything to eliminate. All right, so what I know right now is it could be linear. All right, it could be absolute value, or it could be quadratic. So there's nothing right now that has eliminated, all right, our three choices. So we have to go into rates of change, right, and see what's happening with those rates of change. So let's look at how our x's are changing. Plus 1, plus 1, plus 1, plus 1. And we do the next three, we can see that those all are plus 1. All right. So now what we know is, all right, all of our x's are going up by 1. So let's look at how those y's are changing. All right. So when I go from 46 to 28 at the top of our table there on the right-hand side, we go down by 18. When I go from 28 to 14, I go down by 14. Now, right now, this helps us because negative 8 to 1, or negative 18 to 1, and negative 14 to 1 are not equal. They're not the same rate of change. All right, so that means we do not have a constant rate of change, which means we can throw that dude out the door. All right. Okay, we can throw this one out the door, kind of like Green Lantern. It was really, really bad, right? So we can just throw that one out the door too. All right, so, all right, now we're down to quadratic. So knowing what to look for will help you identify your function, right? And so it's really important that you get into that mindset of having the same routine every time you analyze a table, all right, and it will help you process that material. So let's look at our next couple of changes here. So 14 to 4, I go down by 10. 4 to negative 2, I go down by 6. So there's that pattern we have to analyze. So now we know it's quadratic, so we have to ask ourselves, how are those values changing? So when I go from negative 18 to negative 14, I added 4. When I go from negative 14 to negative 10, I added 4. When I go from negative 10 to negative 6, I added 4. So we can see that these guys are changing by adding 4 every time. So to get my next change of y, I have to add 4 to negative 6. So now I'm only going to subtract 2. So negative 2 minus 2 is negative 4. Right? To get my next change of y, I have to add 4 to that. So negative 2 plus 4 is positive 2. I get to negative 2. What do you see? Anything? Lighten it up? All right. What happened right there, right? We hit our turning point, right? We can see that we came back up the ladder. We have that symmetry. We have negative 2 above negative 4. We have negative 2 below. All right. So there's an example of the turning point was just off the table. We just couldn't quite see it, but the rate of change will get us there. All right. And so now we should see symmetry, right? So I have negative 2 above negative 4. I should have negative 2 below. Above negative 2 is 4. So if everything works out, hopefully I get to 4 as well here. So now, add that 4 there. So 2 plus 4 is 6. All right, so there's my next change of y. And notice what happens. Negative 2 plus 6 is positive 4. And there's that symmetry. Right, so we have lots of things built into the process that will help you and guide you, all right, to determining what type of function it is. All right, so symmetry, turning points, rates of change, all right there for you. And once again, how do we describe the rate of change here? It's increasing by 4, right? Negative 18, negative 14, negative 10, negative 6, negative 2, 2, 6. We can see that it's just going up by 4 every time. And that, my friends, means it's a quadratic function. All right, so that wraps up this lesson, which is lesson 5. So what you need to do now, all right, is turn off the video, get onto Schoology, all right, and do your video check-in for lesson 5. Submit those. Let us know what you have questions about, what you need help with, and I look forward to seeing you tomorrow in class. Have a great night, folks.